I'm going to talk about two different approaches to doing this question. The first one, I always just go with speed equals distance over time, or I normally do anyway, and it checks out. It gets a bit algebraic and everything, but with a bit of practice, it works nicely. And I'll give an alternative, quicker method as well that the solutions give, but I never think to do it like that. So let's talk about Jack's speed. It's going to be the distance that he's traveled divided by the time that he's taken. And then Jill's speed, she's going the same distance to the top of the hill, but it takes her 90 minutes longer. Now I'm going to work in terms of distance per minute, meters per minute, or whatever it is we're measuring the distance in, just to make life a bit easier rather than doing 1.5. So I can rearrange this to d equals vj, Jack's speed times time, but also d is equal to Jill's speed times time plus 90, and I can set these equal. So v Jack times time is equal to v Jill times t plus 90. Okay, that's the little equation that I've got that relates the two speeds together. We need some more information. And then we're told that on the way down, Jill calculated that if she had walked 50% faster and Jack had walked 50% slower, then they would have arrived at the top of the hill at the same time. So that means if we take Jack's speed and multiply it by 0.5, because that's walking 50% slower, and we times that by time, because it's now going to be the same time. Arguably, I should change that to a different time, so maybe I'll call it like little t. Then that would equal Jill's speed, but we're increasing it by 50%, so 1.5 times Jill's speed, and then she's going at the same time. So what does this tell us? We can cancel out the times, we can divide through by 0.5 and see that Jack was actually going 3 times as fast. That makes sense because if we decrease that by 50%, we get to 1.5. And so if we increase 1 by, like, times it by 1.5, we get to 1.5 as well. Right. I can now work out the time taken because I can substitute in to here. This gives 3 times Vji t is equal to Vji, Jill's speed, times t plus 90. I told you it got a bit algebraic, but it's working out, which means 3t is t plus 90, which means 2t is equal to 90, and therefore t is equal to 45. So that is how long Jack spent going up the hill, because Jill then took t plus 90. So in her case, it took 135 minutes, or 2 hours and 15 minutes. So a solid approach here. Hope you're happy with that. All right, here's the second method that I think it's really nice. I just would never have thought to do it like this. So it avoids all the different speeds, distances, and times. This is how it does it. It says, right, let's let Jill take t hours to go up the hill. Then Jack took t minus 1.5 hours because remember, Jill took 90 minutes longer. So if Jack had walked 50% more slowly, he would have taken twice as long. It's going to halve the speed, it's going to take twice as long. So we just double the time to 2t minus 3. Remember Jill says that if that happened and she walked 50% faster, then they would have got to the top at the same time. So let's now look and see how long it would take Jill if she walked 50% faster. So that means we're timesing her speed by 1.5 or 3 over 2, which means we times her time by 2/3 because it's just the opposite. If we double the speed, we have the time. If we times the speed by 3 over 2, we times the time by 2 over 3. So her time becomes 2 over 3t because remember it's her actual time. And then we can create an equation involving t. multiply through by 3 to give 2t is 6t minus 9, and solve that to give t is 2 1/4. Nice method as well, definitely worth sharing.